All right, so there are some properties relating to triangle that your book does not really cover. However, I think they're really important for you to see just moving forward and for the ACT specifically. They're pretty simple, but I want to make sure that we talk about them now while we're already talking about properties of triangles. So the converse of the Pythagorean theorem, remember converse, which just means we're going to switch the if and the then statement. So the Pythagorean theorem, in general, says if you have a right triangle, then a squared plus b squared equals c squared. That's true. And you all know for Pythagorean theorem, c is the hypotenuse. It's the angle, or sorry, the side that's across from the right angle. And then a and b are legs, and it doesn't matter which one we label as which, as long as we're only labeling legs a and b. So what the converse then says is if a squared plus b squared equals c squared, then you have a right triangle. So for instance, we learned today that you could put any amount, or there are certain numbers that you're allowed to use to create triangles. So for example, I know that, let's pick an easy one. All right, I know that 5, 12, and 13 make a triangle because 5 plus 12, 17, is greater than 13. So I know that I can classify this as a triangle. I can say, yes, this is a triangle. But what I also want to do is say, how do I know what kind of triangle it is? So because they're different, we can say that it's scalene. So that's classifying it by its sides. But what about by its angles? And some of you already know that this is a Pythagorean triple, but we know that this will make a right triangle because if I assume, well, and this is not really even an assumption, it's a statement. 13 is the longest side. So if I label that one as C, then I can say 5 squared plus 12 squared. And I'm kind of asking this as a question to myself. Does that equal 13 squared? And if you work that out, all right, that's 25 plus 144. That's 169. And then if I square 13, I get 169 also. So because those are equal to each other, then that means that this is also a right triangle. So the question is, what if they don't equal each other? What will that mean? So let's look at two types of examples. Okay, so let's look at these other two examples. So from today, we know that this first one, 6, 6, and 8, does make a triangle because 6 plus 6 is 12, which is greater than 8. So yes, this does make a triangle. We also know that because 6 and 6 are the same, that this is going to make an isosceles triangle. Did not spell that right. All right, and then what we want to do now is try to classify it by its angles. So I'm going to set up 6 squared plus 6 squared, and I want to compare that to 8 squared. I want to know if they're equal. So if, you may already know the answer to this one right away, that they're not going to be equal, but let's set that up just to make sure. All right, so I've got 72 on the left side and 64 on the other side. So the way that you want to think about this is that if this were a right triangle, then these two legs, 6 and 6, would make for a side, a C, a hypotenuse that would need to be 72 squared. This is what you want if you want a right triangle. However, 64 is what you're stuck with because you've got 8 squared, which means your side over here is too small. And so if you think about that, instead of, you can put your two hands together if you need to, like at your palms, and try to make a right triangle. Well, it's what you've got is too short. So if you kind of push your hands together, you should see that you're creating, instead of a right angle, that angle between the two sixes. So I'm talking about like right here. This angle between the two sixes is pushed to be a little bit smaller so that it fits that third side, which means that is going to give you an acute triangle. Okay, and so with this acute triangle, we can write a rule. So we need to be looking at the c squared. So our rule, we need to be looking at the c squared. So our rule is that c squared, if it's less than a squared plus b squared, then we're going to have an acute triangle. So you can probably imagine or guess then what the other statement should say. But let's go ahead and work that next one out. So on this next one, 2 plus 3 is greater than 4. So yes, this is a triangle. It's an example of a scalene triangle because all three sides are different values. And so I'm going to set this up, and I know to set this last number as the c because it's the greatest number, not for any other reason. So 2 squared plus 3 squared, and we're going to compare that to 4 squared. All right, so that's 4 plus 9, so 13. And on this other side, I'm getting 16. So think about that. We want that third side of our triangle to be 13 when you square it, but the side that I have is giving me 16, which is bigger than what we want. So now, instead of 2 and 3 making a right angle right here, my 2 and 3 are going to have to stretch to make a larger angle to meet that bigger side. So that means that this is going to be an obtuse triangle. And so our statement is going to be that if c squared is greater than a squared plus b squared, then we're going to have an obtuse triangle. So we'll look at a few of those problems tomorrow. All right, and then we also have this last set of properties, and this is with isosceles right triangles. So there's some special things going on. So first of all, right triangle obviously means I'm going to have 90 degrees. Isosceles, we learned today, means that 2 of our sides are the same, and it also means that our 2 base angles are the same. So remember, this 90 degrees is my vertex angle, making my base the hypotenuse, and these other 2 angles are going to have to be the same. Well, if I work that out, or kind of think about that for a minute, in a 90-degree isosceles triangle, those 2 base angles are always going to be the same thing. And I could set up a little equation to solve that. X plus 90 equals 180, which would give me 2x plus 90 equals 180. And if I subtract 90, 2x equals 90, which means both of my 2 angles are going to be 45 degrees. Okay, so we want to change that about our problem, or add that in, that in isosceles right triangle, these 2 angles are going to be 45 degrees. And actually, this is a special name, 45, not 40. There's a special name for this, and it's called a 45, 45, 90. All right, that's how they refer to these triangles. And so not only do we know that the 2 angles are 45, but there's a special relationship that exists between the sides all the time. So if these 2 legs, let's say, we don't know what they are, but we know they're congruent. So let's call each of those x, okay? This hypotenuse will always be related with the same kind of proportional value. And because this is a right triangle, I'm going to know that Pythagorean theorem does work, which is what we just reminded ourselves, which means I can do a squared plus b squared equals c squared. All right, so stick with me. I know the 2 legs are both x, so that's x squared plus x squared equals c squared. I don't know what c is yet. Well, I can't really do a whole lot to solve, except all I'm trying to do is get c by itself, so I can see is there a rule for the hypotenuse. So x squared plus x squared, that's 2x squared equals c squared. And then I can take, to get c by itself, I can take the square root, which gives me that c is going to equal, the square root of x squared is just x, and the square root of 2 is square root of 2. So this c, which is the hypotenuse, is always going to follow the rule, no matter what the x's are, of x square root 2. All right, so what that means is that's going to give us a shortcut where we don't actually have to solve out the Pythagorean theorem every time. All right, let me give you 2 quick examples. All right, so in these 2 examples, they're asking us to find all the missing sides. So in my first example, notice that they've marked that these are isosceles right by showing that these 2 acute angles are congruent to each other, which means I know the 2 sides across from them are also congruent. So if one of the legs is 7, then obviously I can find that the other leg is 7. And what that rule just told me was that the hypotenuse is in the same proportion of x square root 2. Where x is the leg side, which means this hypotenuse in length is going to be the same as 7 square root 2. Okay, we'll talk about kind of how to set these up and solve these a little bit tomorrow, but I hope that you see that that ratio is applying and I'm not having to work out Pythagorean theorem. All right, on this second example, this one's a little bit different because what they've given us is this hypotenuse side. So I don't know the leg side, but I know the hypotenuse side is 16, and the ratio for the hypotenuse is x square root 2. So this time I'm going to set up an equation. X square root 2 equals 16. Because I need to know what x is so that I can find these two missing legs. Well, to solve for x there, I can divide by square root of 2 because that's being multiplied, so I need to undo that. So that's just going to be x equals 16 over the square root of 2. But hopefully you remember from last year that you are not allowed to leave square roots on the bottom. So we have to do what's called rationalizing, where we multiply by the square root of 2 over the square root of 2. Now, if you haven't done this yet and I need to spend more time tomorrow, that's fine. But just kind of get this down, at least as the basics for your notes. The reason that this is helpful because the square root of 2 times the square root of 2 is the whole number 2, right? That's the square root of 4, and the square root of 4 is 2. So this is going to give me x equals 16 square root of 2 over the whole number 2. Or the easiest way to write that is just 8 square root of 2. Because what I've done, I can simplify or divide that whole number fraction 16 over 2. So the final answer for the two legs here then is going to be 8 square root of 2 on both of them. All right, so these are just some final properties to wrap up triangles. We will go over these tomorrow, spend a lot of time in class just working and practicing, and then you all should be kind of good to go for your test coming up on Friday.